I'm speaking? Is any sound?
It looks like it's picking it up.
Okay.
But okay.
Oops, that's not what I meant to do. There's this, and let's go to the right here. Okay.
Awesome.
All right.
I'll introduce Julia. And
right.
This is Julia. She works for Stack Overflow. Wonderful company. If you guys do not know Stack Overflow, you should. It's a great place to get all your R questions answered without the how do you put it? The vitriol that you get from the mailing list, the snarkiness.
The grumpiness.
Grumpiness, that's a good way to put
the
it.
Grumpiness of the R help mailing list.
Yeah, so for those of you who were not at our last one or did not see our last one, we have started recording and live casting these on YouTube. I have set up a UtahRUG users group YouTube channel now. So all of our meetings, we will try and record them and archive them there, so that if you don't happen to get here in person, which we try to entice you with things like pizza and candy and stuff like that. So, so it's better for you to come here. But if you can't, watch the live stream or catch up afterwards. So we're going to get some good stuff in the next couple months. And if anybody wants to present, all you need to do, email me, tell me the time that you want to present and where you want to present, or if you need help finding somewhere to present, let me know. We'll set it up. Whoever is presenting kind of gets to choose the time and place and whatnot. So if you've got something to present, just let me know. All right.
Great. Thank you so much, Andrew, and thank you for all your work in facilitating these meetings and organizing them. So today, what I'm going to be talking about is getting started with Shiny, an introduction to Shiny, and what Shiny is and how you can use it to communicate analyses that you have been working on in some new ways. So yeah, my name is Julia Silge, and this is me on Twitter, and this is my website, and I'm really glad to be here to help us get started on how we can use Shiny to do some things that we want to do. So if you're here with a laptop and you want to work along through the tutorial that we're going to be doing, which I encourage you to do, because doing something hands-on is definitely a great way to be able to remember. Learning by doing is certainly a great way to do it. Here are some packages that we're going to be using in our getting started with Shiny tutorial here. So we've got some packages from CRAN up at the top, and then the only reason we need DevTools here is because we're going to install a package from GitHub down here at the bottom. That's going to be the data that we're going to use in the Shiny app that we're going to build here together today. So that data is actually from is Stack Overflow data. So we're gonna use some Stack Overflow data in the Shiny app that we're going to build together today, and it is Stack Overflow data from the Stack Overflow survey from last year, and it's a big week at Stack Overflow this week actually, because the Stack Overflow survey from this year was just released yesterday, and so we've been working really hard on that. So I thought, why not? Let's do it. So that data this year's data isn't public yet. We just finished a first analysis of it and put our first report on the web yesterday, but we will be making that data public when we get it a little more cleaned up and ready for public consumption. But so this is last year's data from the 2016 survey. So this is what we're going to use. So make sure you've got all these packages on your computer here, and let's get started. So let's talk about what is a Shiny app. So Shiny is a framework for building interactive apps using R. So it's a way that you can take an analysis that you have done as like a data scientist or analyst, and you can take something that you've built, like a plot or a set of tables or something that you built, and you can build something that is going to be interactive using just what you know in R. So a Shiny app is served It is run by a computer. So it's run by some kind of computer that you can think of as a server. So we have to have some computer somewhere that is going to be running the app. And then it is presented to a user who is going to be the one interacting with the app and doing dealing with it. So let's make one right now. So let's go to let's go to R, if you've got it open. So let's go to RStudio, if you've got it open, and let's go up here to File, New File, and let's go and open up a new shiny web app. So today we're going to talk about making single file web apps. So make sure you have clicked here, single file, and then we're going to give our application a name. So I'm gonna call this Utah our user group, and it's going to create it wherever we want it to. I think this is fine for me right here. So let's create one, and it's going to make a basic shiny app here that is just like a starter shiny app here for us. So let's look at some of the parts that are here. So up here at the top part, we have some code. I'm going to make this bigger. There we go. Is that? I'm going to make it like that. Okay, so up here at the top of this file, this app.r file, we have some section of code that is outside of any functions. So this is part of the app where we can put code that all the functions will know about. So we can put code here that we can define data objects, or we can run code here that everything later in the app is going to know about. After that, we have a function that's called UI. And UI is, in fact, the part of the app that is going to tell us what is the app going to look like. And so we've got some things here. You see it's got like fluid page and title and sidebar. So these are the things that are going to say, what does the app look like? And then the second function that we have here is called server. And so the server is the behind the scenes calculations that are being done. So our app, so far we have a section outside of the UI and the server where we can put code that needs to run to get ready. To get ready before we start the app. Then we have the UI part that's going to say, what does the app look like? And then the server that does the behind the scenes calculations. And then down here at the bottom, we have a line of code that says, okay, time to run the shiny app. So notice it takes as its inputs, it takes the UI and it takes the server here. So let's see what happens when we hit run app here in RStudio. So the code that was in that file that we made makes this app. And so it's got one input over here where we can change the slider on this the number of bins here, and then it makes a histogram over here, and it changes how many numbers of bins we have here. So this shiny app has one input that changes the number of histograms, and then it has one output, which is the plot. And notice, pretty snazzy, as I change the slider here, it changes the number of bins. So this app is reactive in that when I change something in the input, what changes in the output changes as well. So so notice that I just hit stop. So I hit run app and it started. And it's kind of responsive here. It'll change what it looks like here. So when I hit run, it opened it in the little window here inside of RStudio. I could hit open in browser, and then it will open. And now notice that it's in my Chrome. I can open this in a browser to see what it looks like here. I am gonna close that. Go back to RStudio over here. If I hit X here, it's going to stop running it. Notice what was happening down here. It says run app and then the name of the app that I hear. And notice that it was saying listening. So the computer that's acting as a server for the app that we just are making right here is this laptop that's sitting right here, that's the server that is serving this app. So anytime you have a Shiny app, it has to run on a server. Some computer has to be doing the behind the scenes calculation to serve the app. So in this case, right now, it is this computer right here that's doing the server. So that is a super simple example of a Shiny app. It had a UI, it had a server. We saw it do some things here. I noticed that I could close the app by hitting the little X button. There's also a stop button in RStudio that you can use to make it close down. Remember that if you're doing this in RStudio or in R on your computer, that your computer is the one that is serving the app. And notice that the app is reactive. There are different ways that you can view the app. You can run it in your viewer pane, which means this part right here. You can run external, which means to run it in a browser window, or when I had it to run in a window, which means that it popped it out in a separate RStudio window. All right, so this is how we get around running a Shiny app here. So Shiny is a very flexible and extendable web framework. So I just showed a really simple example of a Shiny app, but let's look at a complex example. Did we click? Yes, okay. So that thing I just showed you was a Shiny app, but this is also a Shiny app. So let's say I'm gonna look for Salt Lake City here, and I search for it, and it didn't work. Let's just try Salt Lake City. There we go. Okay, so we find all these cities here. Let's find Slick City here, and it tells us this information here about not Slick City. Let's find the community college here. So we find it gives us some information about the community college here, like how many students are here, some information, a little map about where it is. If we scroll down, we get more information about this university. It doesn't have information about the admission rate, but if we were to have clicked a different one, like Westminster or something like that, we could find it. So this is also a Shiny app. That's not what I want to do. And let's look at how this one works. There we go. So this is the code that makes this Shiny app. The reason I'm just showing this to you is so that you can see how flexible and extensible Shiny as a web framework is. So let's look at so notice here that we have, let's look at the server.r first. So notice that this is R code in here. So if there's a lot of R code connecting to a SQLite table, and it does a lot of things in R to get the information that we need. And if we look at the UI here, look what does it do? It goes to this directory and it gets an HTML file. And it gets this file, which is HTML. So Shiny can, if you are someone who has web development background, Shiny is something that you can use basically to make any kind of web app that you want, but you can use R to do the server side back end things that you want it to do. So Shiny is very extensible and very flexible, and you can do a lot of amazing, beautiful things with it. So let's go back to how to get started with Shiny here. So let's talk about inputs and outputs. This is the way Shiny sets itself up and works. So Shiny is a reactive framework, a framework for working with reactive inputs and outputs. A Shiny app has a UI and a server function, and reactive inputs and outputs are passed back and forth between the UI and the server function. So the UI is the part of the app that controls how the app is laid out, what is it going to look like, and and the server function has the instructions about, like the behind the scenes instructions about what calculations are going to be done and how are we going to go about building this app. And the way that these two things interact between each other is by passing back and forth reactive inputs and outputs. Many of us who come from analysis backgrounds or science backgrounds are used to writing code, or R code or any kind of code in what might be called like imperative or procedural kind of styles. Like we're used to writing, or maybe we're functional programmers. Like we're used to writing. Okay, I'm going to write my code. It's going to go down, and it's going to we're going to write code that's going to go down through the script, and it's going to do what I tell it to do. Reactive programming is a different paradigm to think about code that focuses instead on how is data going to flow through the code and how are changes going to propagate. If a user changes something, if a user changes something in what they're doing as they're interacting with the app, how is that change going to propagate through what's going on with the data in the code, and how will that affect the output of my code here? So let's talk about the kinds of inputs and outputs that are available in Shiny. So here are some inputs here. So some really common ones that I use a lot are the select input, which also involves allowing you to select multiple kinds of things. But we saw a little example of the slider input. I also end up using a checkbox input a lot. So, but you see lots of different kinds of inputs that we're used to using as we use computers and web forms and things like that. So these are all different kinds of inputs that are available in the Shiny framework. Here are some examples of outputs. So this is all these two bits of that I'm showing you are available from RStudio and on their Shiny cheat sheets that they have there. So here are some examples of some outputs. So the inputs are things that we take in from the users. So we've got the things that, what is the user telling us? Are they clicking something? Are they sliding something? The outputs is going to be a reactive output that we're going to do something with after we have some server-side thing that we're doing. Is going to be something like a plot, or maybe we're going to print something, or maybe we're going to make a table. So these are examples of things that we can have as the output of our app. So we're going to have inputs to our app, and we're going to have outputs to our app. Yes.
And so the inputs are normally in the UI portion of the code.
So our
Would
UI.
you repeat the question for the?
Yeah. So he asked, do the inputs go into the UI? So in the UI of the code, you organize where do the inputs go, where do the outputs go, and the server, and you pass inputs and outputs to the server, and the server says, how are these things related to each other, and what do we do with them? How do we take the inputs and get the outputs from the inputs? That's how these things are related to each other. So let's do something. Let's take some first steps to reactivity. So reactivity occurs when you take an input value and you use it to render an output object. You make some kind of object here. So let's start to make a Shiny app together. So we're going to use some of the survey data from the Stack Overflow survey from last year. So we're going to make a select. We're going to make a drop-down select box here. So we're going to do it. So the Stack Overflow survey had respondents from all over the world, and one of the questions we asked them was like what country they were from, and there were many hundreds of countries, so we divided that up actually into regions in the world. So let's look at that here. So let's go up here and let's do some things here. So first of all, I'm gonna change the title because we don't want to say anything about Old Faithful. It's not going to be Old Faithful anymore. Let's call it Stack Overflow Survey 2016 here. And let's, so I'm going to start putting some code up here in the top section because this is the section where I put code that I want to, I want to run one time when the app is spun up. And this is, I can define any objects that I want to be available to both the UI and the server. So, and also I want anything that I define up there is something that cannot be changed by the user. So it's just something that's going to be defined one time and will not be changed by the user. So I'm gonna, remember I told you we're gonna use that that data from the survey. So that is in a data called, that is in a library called stacksurveyr, surveyr here. And let's look at what that data looks like. It's kind of long. Let's see if I put it in my, here, it's just a problem. All right, just show it to me. I don't think I have. All right, one more time. Okay, so we've got, for each respondent, we have where did we get there, where did they come into the survey from, what country are they from, what UN subregion, and SO region. That's what we're gonna start. We're gonna make a drop-down box for what region are they from, is that are from this. And if we keep looking this way, whoops. No, anyway, we can keep going. There's lots more data columns this way and so forth. Okay, so we are going to load the stacksurveyr library up here, and then let's start to make an input. So we have a slider input here, but we are not going to use a slider input. We're going to use a select input. Let's look at what select inputs look like. So select inputs take a few arguments. The first one is the input ID. The way inputs and outputs work in Shiny is that they're passed back and forth as strings. They're passed back and forth as the name. So the UI and the server talk to each other by saying, here's this thing, and the name of it is a string. So we have to call it something. So we're gonna change this from slider input to select input, and we're gonna select a region here. So I think let's call it region. I think that makes some sense. This second thing in here is the label. So let's call this. Let's just put region. So this is the thing that's going to print out. This is just literally what's going to print out in front of the select box. We could, for example, we could put, if we wanted to be a little more wordy, we could say choose a region. And this is what's going to print out for the user so they know what it is that they're doing. And then we need to say the choices that are going to go here. Whoops. Choices. And so we have to decide what the choice is going to be. So let's look at in stacksurvey SO region, what have we got here? So we've got a whole bunch of strings, right? If we just put this value, if we just put stacksurvey SO region, there's a lot of repeated values there, and it's not going to work so well. So what we actually need to do is to take each one only one time. So let's take a unique of each of those. Notice we've got some NAs. So I think, I cannot see there's my. All right, so our choices here are going to be unique of the regions. We've got some NAs, so I think it's time for us to put some code up here. Let's say survey selected, and let's take the stack survey data object, and let's do some filtering. Not is NA SO region. And whoops, I gotta load dplyr too. There we go. Okay, so now otherwise, NA is gonna be one of the options here, and that doesn't really make a lot of sense. Okay, so let's do that. Let's delete some of this other stuff in here because we don't need it anymore. We don't have that data. And let's say behind the scenes calculations that we will get to in a minute. All right, so right now, this is gonna be our input. We're saying, okay, we want our user to choose an input here, and then this is the output. We're saying plot output, and we're saying it's something called distplot, and we define distplot down here in the server function, and right now it's empty. So it's just gonna return something empty back up to us. So let's see what happens when we run this. All right, this is actually what we would expect to happen right now. So we changed the title, and we got all the regions from the data here. And so we can select these guys, and we have an empty plot over here because we're returning nothingness. We're just returning emptiness. Yes.
Quick question. The thing where we got rid of the NAs.
Yes.
Where did that go back into the?
Yes, you're right. Are NAs there, or is it? Yes. Smart. I defined it, and then I didn't use it. There we go. All right. So notice another thing here. We can select one of them. We can say there's one of these things that we want to start with. Okay, which one do we want to start with? If we don't start with any of them, it'll just pick the one that's first in line, in alphabetical order. So let's pick North America because that's where we are. All right. So this is the input. So the input is called input $region, and that's because we called it region right here. So since we called it region, it's going to be passed to the server in input right here as something called region. So we can access it in the server function as something called region. And then the server function is going to take all the inputs and do some things and then send it back as something called output. And output will have things called whatever we do down here. So let's look at some salaries. So let's make a salary plot, and we have to change this name here. And so we will make something that is an output here called a salary plot, and so forth. All right, so so far we made an input. So let's go back to some slides and talk about some things. So we did this. We made an input here. And now let's talk about making an output. Let's talk about making an output plot. We've got our data, and we can put information. We can take the input information we got, which remember is just which region do we want, and we can use that to make a plot as we go out. So this is just going to say we're going to take the survey that we want, and notice let's filter so that we just get the region we want, and then we're going to calculate an average salary for each occupation of people who took the Stack Overflow survey last year, and then we're going to make a bar plot for each occupation. So let's do that here. So notice that we're going to do that inside this RenderPlot, inside this call to RenderPlot. So RenderPlot, notice that it has, let's get rid of this and start over with RenderPlot. So RenderPlot is a function call, and we usually do something like this with the curly braces to as a visual cue to ourselves that this is a reactive object. So RenderPlot is a reactive output. So when we did select input, that was a reactive input, which means it knows to be watching. Is the user changing anything? Is the user changing anything? And then it will say, okay, time to change. And RenderPlot is a reactive output. And so it knows to watch the inputs and to say, is anything changing? Is anything changing? And if anything changes, it will know to update here. So that's what those two sets of brackets mean, is that they are visual cues to say, okay, parentheses, curly brackets, this is going to be a reactive output of something that we can do here. So let's speed through making a plot here. So we've got our, what did I call it? I called it survey selected. Okay, so let's call it survey selected, and we are going to, let's filter out things that are not, that didn't have an occupation, people who didn't fill out the occupation, and there were some people who said their occupation was other. Let's not take them. And then let's group by occupation, and then let's find a mean salary. Let's call it av salary. And let's take the mean. Oops. I think that's what it's called. Did I not run this? All right, I ran it, so now I have it, which is better, because then I can have some autocomplete help. Who can code without autocomplete? Not me. All right, still not auto-completing. Okay. Okay, I think, let's see if this works. What's it called? Salary midpoint. Okay, so we did that, and now let's let us arrange it in descending order of salary. So that we get a nice bar plot that goes down. And then let's reorder the occupations. In the, so that also this will make a nice bar plot in salary like so. And now this we can pipe to make a plot. So we're gonna put the occupation on the x-axis, and we're gonna put the salary on the y-axis. We're gonna make a bar plot. So let's do geom call. I don't want it to be black. Let's pick some color, and let's make a theme, because I don't like gray backgrounds. I like white backgrounds. Theme minimal, base size, something like so. And we got we're gonna chord flip it so that the bars go the other way, so that we can read the words and they don't overlap all each other. I think I didn't load ggplot2 at the top of this. So you have to load all the libraries that your Shiny app is going to use. They have to be loaded in the app itself. So let's see. Let's go back down to our where we're making the plot. So notice we're inside of plot. We were inside of RenderPlot, and we've typed a whole lot of lines of code here that are going to make a plot. And so it's going, what RenderPlot is going to do is going to try to render a plot. It's going to render a reactive plot. If we had said render text or render print or render table or something like that, and we put a plot inside of it, it's not going to work so well. So, so we have to match up the kind of thing that it's going to do with this. Aha, I made a mistake. I used fill instead of color. So we can fix that. But this worked pretty well, right? So we made a plot. We've got all the kinds of occupations that we took on the people who took the survey last year, and then we see what were their average salaries. So, and if we switch over here to a different kind, let's say we switch to Africa, and we see that it doesn't do anything. Super exciting app I made, right? Why didn't it do anything? I didn't use my input, right? I never used my input to do anything. So let's fix that. Now we have to use the input, okay? So the important step right here, we have to use the input. So let's filter not only on these occupation things, but let's filter so that SO region equals the input, what did we call it? Input region, like so. Like this. And so this is now what's going to make the app reactive. Before, it functioned, it didn't error out or anything, but I didn't actually use the input. So it was rendering an output, but it didn't, since I did not ever actually use the input, nothing happened there. All right, so let's let's change some things real fast. Change some labels. And this is always kind of nice to make some nice labels here. So we're going to say that the labels on that are going to be dollar format. Let's do that. Okay. All right, let's run this. Let's see what happens here. We got a little squish. There we go. Okay. Let's see if we got some more actual reactivity this time. Do we not? There we go. All right. So now we see some actual something good. So now we can see that in different parts of the world, different occupations, first of all, have different salaries, right? Which these are all converted to US dollars. But also, different things are more highly paid in different parts of the world. So in Africa, being a database administrator is very highly paid, even above executives apparently, whereas
and they still pay Windows Phone developers.
Yeah.
Yes, yes. Whereas in the United States and Canada, we see that these executives are the highest paid, with engineering managers beneath there. So we've gotten to something that is interactive, because we made an input, we made a way to get an input, and then we used the input in the server function. Then we made the plot output, and then it passed it back. So the UI is what made this laid out the way it was, and then the server function is what took the input, did something with it, and then passed it back. So let's talk about a few more things here. Since we are very short on time, I am going to so I'm going to go over a few things. I want to do kind of talk about this. What if I said, well, maybe I would like to see what all those numbers are. I would like to show a table. Beneath my plot, I want to show a table. So let's use a checkbox input. So a checkbox input, we have to give it a name. We have to give it a input ID. We have to call it something let's call it show data. So that's going to be what goes in the input $ show data. That's the string that's going to get passed from the UI to the server to say, do I want to show the data? And it's going to be either a true or a false. And we can put a label there. We can say show table. Do you want to show the table? And so let's add that here. Okay, so let's go up to the UI. So here's what we're going to do here. We're gonna do a comma here, and then we're going to say checkbox input here. So let's call it show data. Then the label is going to be show table. That's just what's going to print out next to it. That's just a label. And then we're going to say, I forget what it's called. Checkbox input. So then the value, so this is the default value. Well, this is the default here. I guess I could have skipped saying that. Okay, so let's see what this looks like. Remember, I'm not using this yet, so it's just showing up here. So I can click this on and off, but remember, I'm not using this yet in the server. So it's like true, false, true, false, true, false. Nice. Good job, Julie, that says. Good job. Okay, so we made the input. Great. So let's try to use it now. But I don't want to have all that dplyr code 2 times. That would be silly, right? So let's use a reactive expression. We want to make one object, and then we want to use it twice. We want to use it one time to make the plot, and then we want to use it one time to make a table. So we're going to make a reactive expression like this. We're going to take all of our big data that had all of the individual people in it, and we're going to make a summarized summarized table that's going to say like executive and their salary, and web developer and their salary, and all the way down. We're going to make it one time, and we're going to use it both to make a plot and to make a table. We're going to use a, quote, reactive expression to do that. So a reactive expression, we've already been using reactive expressions. The RenderPlot expression that we made is a reactive expression, but you can actually make anything a reactive expression by putting it inside of reactive like that, just like we have that. So a reactive expression uses input from the user, and it returns a value. And it, like RenderPlot, it knows it's reactive. So it's looking for input from the user. It says, is it changing? Is it changing? Is it changing? It knows to watch for any inputs and will update its value whenever anything changes. So the best uses for reactive expressions are when, for example, like this, when you want to avoid rerunning unnecessary code. You only want to call a reactive expression from within another reactive expression, or a render function, like a RenderPlot or a render data table, render table, or something like that. If you try to call it from something that's not reactive, the whole thing breaks. It doesn't work. No good will come of this. So if something is reactive, you can only deal with it from something else that is also reactive. You have something that understands about reactivity. So so now that this summarized DF here that we're about to make, we can only do something with that object from within a context that is also going to be reactive there. So a reactive expression is something that is meant to return a value. It's meant to be looking for an input and return a value. So this is not something that you want to have any side effects. So, Joe Chang is the developer of the Shiny framework, and so at the Shiny DevCon like last year or so, this is one of his slides. And so he says that an easy way to remember about this is that he says, keep your side effects outside of your reactives or I will kill you. So none of us want to make Joe Chang mad at us. He's super nice. So remember, no side effects in your reactive. So that would be something like changing something in your environment, or saving a file, or doing something like that. You don't want to. It's anything but returning a value. You want to do, like if you're familiar with functional programming type stuff, you only want to return a value with reactive. You don't want it to be changing anything else in your environment there. Did you have a question?
That was my question, is to find the side effects.
What is the side effect? Yeah. So remember, reactives only return a value. You don't want it to do anything else but return a value there. Okay, so let's do it. Let's make a reactive. We'll do that and we'll use it, and then we will wrap up by talking about how to share these. Where did it go, the plot? Okay, so reactives go in the server. So we're gonna take this whole bit all the way up to the plot right here. Do you see what I've got selected? I'm gonna cut it, and I'm gonna go here. I'm gonna say, let's call it selected data frame. And I'm gonna say this is a reactive thing. Notice that I'm adding the curly braces here. This is a visual cue for all of us to know this is a reactive thing. And I'm gonna paste the whole thing in there. So now this is a reactive thing that I've just made. I've just made a reactive thing. Congratulations to us, right? Great job. Okay, so I'm now gonna take my new reactive thing and I'm gonna put it in here. All right. Now, if anyone have you shiny, or you just saw me do that, you're like, wait, you forgot something. And I did, I forgot something. Everyone watch really carefully. Are you watching? Okay, that's super important what I just did, because the reactive thing that I just did is actually returning a function. It's a reactive thing that's returning a function. So anytime that you use it inside of your reactive, inside of your reactive context, you have to use it like this, as if it is a function that is returning something. So it has to have those parentheses, because that's what it's doing. All right, so let's so we could run this right now, and I'm pretty sure it would work. But let's add the last thing that we're gonna do right now, which is to add a table showing the same information. So let's call it salary table, render data table, like so. And we're gonna take that. I might have to cheat and look. Or maybe it's DT. I'm gonna have to cheat and look. Sorry, everybody. Ah, yes, of course. Okay, so this is what we've got for our last thing here. We're gonna render our data table, and we need that if statement, and that's the reactive thing. That's what's gonna make it show it when we have it clicked, and not show it when we don't have it clicked. So we're gonna say if input show data, and then we're gonna say the data table is a JavaScript library for showing data tables, which was pretty and makes nice things here. So let me put this in here since we're running so short on time. So what this code is doing here is not happy. Render data table. Summarize df. All right. There we go. Okay, so what this is doing is it's saying if the checkbox is clicked, render this data table beneath the plot that we had before. And so data table is a library for making a pretty table that we have here. You know what? I'm gonna say data equals. I'm just gonna. salary. Is that what I called it? Yes. Scales, dollar. Okay. All right, so let's see if this works. Like so. We're kind of running out of space, but let's see if it works. Did it work? Did not work. All right, let's see what we've done wrong. What did we do wrong, everybody? It's not here. It's not up here. I made the data table down in the server function, but I didn't put it in the UI. So it didn't actually ever make it up into the UI. So I need to say, what kind of output is it? The table output, or is there a data table output? Data table output. And what did I call it? Salary table. Like so. I think I need a comma here. Like so. That's why it didn't show up, because I didn't tell the UI to put it there. Does that make sense? Why it wasn't there? Let's try it again. Okay. Are we showing up? I called it the wrong thing. Okay. What did I call it here? Selected. And yep. There we go. What do we think now?
Dollar format function. It's like it has a double.
Dollar, say again?
So mutate average salary equals dollar format.
Yeah, let's take that out. Well, that is actually how it works. Yeah.
You can use format currency in data table and then sort it. I don't know if that'll sort.
Yeah, let's just take this part out for now until we get it. Data table, data, selected DF, and it's selected DF there, and input, if input show data, is that what I called it up here? If input show data, all right, data table output, salary plot, salary table, all right, let's try this. Oh, so sad. All right. We are going to cheat and look at my one that's working. Show data, output ID, data table output. Oh, yes. I will be honest. Oh no, that's what I have. DT data table, salary table. All right.
Oh, average table. You were calling it AVG
Yeah. What's
for average salary.
yeah. Try this one more time. Perils of live coding. What? So sad. Okay. All right, does anybody see why it might not be working?
We have to use the DT data table.
You know why it's not working? This is why it's not working. That's why I wasn't working. Yeah. All right, there we go. And if we wanted, we could change the name of these titles if we want to use some other things. We are really, really low on time, so I'm going to keep going. Yes, loading libraries is important in the Shiny app. I even said that, didn't I, earlier? Man. All right. So we talked about reactive and what it means, and how to use them. And so let's just wrap up by talking about, you made a great app. You debugged it. You made it working. What do you do now? How do you share your app with people? So if you want to share your app with someone who uses R and has R installed, you can just literally share the code for your app. You can just send them the code, the .r file, the app.r, and your collaborators can run the app locally. Remember that an app has to be served by a computer. And right now, the app that is serving this app, the computer that has been serving the app that we have been using right now is this laptop that's sitting right here. So that's one option. You can just share code with someone if they are someone who is an R user. If you want to share your app with someone who is not an R user, maybe with some kind of stakeholder in your organization or with the public or something like that, you have other options. You can publish if you want to share your app with everyone publicly, you can publish using an account on shinyapps.io. So this is a service that RStudio has, and they have a variety of options that range from entirely free to super duper expensive if you're like a big company that wants to use that to host their apps. And they have apps, they have options actually also that are not public. They have options. If you want to use shinyapps.io to serve apps that are private, you can do that through them. So I personally started with a free account to use to host Shiny apps that I wanted to show for my blog or for like portfolio type stuff. And then now I pay for a starter account. A few of my blog posts with Shiny apps got a lot of views, and I ran out of time. They give you like a certain amount of server time per month, but the starter account is actually pretty affordable too. It's something like $40 a year or something like that. So that's pretty affordable. Yes?
I looked at that recently. The free account, you get 5 apps. And when you pay for it, you get 25 apps.
Yeah. Yeah, so even the starter account is pretty reasonable, and then they kind of have accounts that are meant for businesses. So this is a good option. If you want to share apps within people in your organization, like for example at Stack Overflow, like we want to share apps with people, like with salespeople or with people who are making decisions within our organization, then you could consider installing Shiny server on some kind of machine of your own, like that you have in your organization. And it is much easier than I thought. I'm not a person that has a lot of sysadmin experience, but with some help for some people who, granted, are super smart and good at what they do, but with some help and a little bit of support, like we got Shiny server running on something, on a machine, and it was really not hard. Like RStudio has clear, helpful instructions, and so Shiny server is open source. It's free. Like you can install it on any machine that you want, and it works really well. I think they have it for like various flavors of Linux, and then you can put all the Shiny apps you want on your own machine, and so then that machine can be the server that's going to serve your Shiny apps, and then you can have people go and look at them, and that works very well. So those, I think, are like the 3 good main options for how you can share your apps once you make them. And with that, I will say thank you very much. So anybody have any questions? Yes.
So, like debugging.
Yes.
I mean, I know that if you just have like a pile of R code, it's pretty easy just to run some stuff in the console. But because this is very like specific like syntax with braces and extra parentheses and things like that, like you're not just going to be able to like run code in the console, just see if it works locally, like before you run the app. So how do you debug?
Debugging Shiny is a little bit different than debugging R scripts. Because it is reactive, and that's exactly because it is reactive. And so there's a couple of things to try. The more the more experience you get at it, the more you realize, like, oh yeah, it was this. Or you see something, you're like, oh yeah, I know what that means. You know, it's like you get these things about the closure, and you're like, oh yep, I forgot the parentheses after my reactive thing or whatever. But for if you do get stuck, there are tools for this. So there you can turn on logs. Like if you Google, it's like Shiny log. You can run your Shiny app with a log where it will print out quite a lot of information about what it's doing and where you're hitting error messages. Joe Chang actually has a couple of talks that are recorded all about debugging Shiny apps, which have been very helpful to me, like getting more in my tool belt as far as like what am I going to do if like I get stuck, or like what kind of approach am I going to take if I can't, like what do I do next, you know, that type of thing. So there are resources out there for how to get going again if you end up getting stuck. But it does feel a little different if you're someone who has programmed a lot in R or in more kind of procedural or imperative style scripting languages. It does feel a little different debugging a reactive app.
Yeah, because I noticed I had like a mistake somewhere, and when I went to run the app, it didn't give me an error; it just showed me a blank window. And it's like, wow, where did that happen? Where did it go wrong? Then?
Yep.
So.
Yep. Any other questions?
Oh, one more too.
Oh, yeah.
When you have the free Shiny.io account and you run out of something, do you get like a notification?
Oh yeah,
to tell you
yeah.
that?
No, in fact they tell you before. In fact, they keep allowing people to see your app for a little bit, and they're like, it's about to run out. Are you sure you don't want to give us some money? Yeah.
Thanks.
Yep.
Great.
Great. Thank
Let's
you
thank
all
you
so
again.
much. Thank you.